Why would you choose to learn networking when you have plethora of other things to learn? So that's so I would be giving some reasons why you should be listening and stuff. The first thing is strong foundation. So that's this is a thing like you have to have a strong foundation because currently the thing is you mostly would be working with high level frameworks, be it Spring Boot, be it Django, or like any big frameworks you would be working on. They have already abstracted out almost all the things, so you don't have to understand how to actually make an HTTP request. You just use a library like Axios or like any other library. You will just use it directly and you will get all the functionalities out of the box. But the thing is, you have to, as an engineer, you have to have these strong foundation when you because the company product based companies tend to create their own frameworks which tend to build them build those frameworks from ground up. So if you are getting placed in a company like Google or like any product based company, they'll expect you to have strong fundamentals. So networking actually like this thing will teach you us will give you a strong foundation in networking. And the second thing is better troubleshooting. So better troubleshooting as a let's say how do you debug not debug how do you fix an internet issue. You will just turn the router on, you will just turn off the router, you will turn it off and turn it on after 5 minutes. So that or you will just plug the ethernet cable out and you will just blow it and you will plug it in. This is a trial and error way of fixing an error. But the thing is, that's not the very optimized way because you are just relying on your trial and error, which is probably very much time consuming, but eventually you will end up solving the problem. But what if you are actually switching it on, switching it off, but the actual issue lies in the cable, the internet cable itself being cut. So you will not be having any clue. Only after doing the trial and error for so long, you will just go out and see, okay, the cable itself is cut down. That's why nothing is working out. So the point here is there are multiple ways to solve a solution. So, sorry, a problem. There can be 100 ways, but if you have a strong foundation or if you know how things work, you can cut down or eliminate almost 95 percentage of the ways and just concentrate on the five paths that might eventually lead you solve the problem very quickly. So I have this quote. Maybe I created it on my own. I'm not sure exactly, but it goes something like if you don't know how it works, you don't know how it fails and when it fails. Because you created a code and only you and God know how it works, maybe also ChatGPT. But when it actually breaks in production, you just copy pasted the code either from the internet or now it's from ChatGPT, and you didn't understand how it's working, and somehow it worked, and you pushed to production, and it started breaking in the production. So, but when it's breaking, you have no clue why it's breaking because you have not even understood why it was working in the first place. So, having a strong foundation and knowing how things work from the ground up or how things work in general will make you a better troubleshooter, which is one of the very important qualities of being a software developer because you'll be spending your rest of the days fixing bugs. Either like you won't be going to create a product like Instagram or like Facebook every day. 95 percentage or 90 percentage of your time will be going to solve some of the bugs which you have pushed the last week or pushed by someone else the last week or maybe yesterday itself. Fine. Okay. So the third point is this is a concept which is must know in the interview because companies, almost all the companies expect the engineers to know very strong, like be very strong in the fundamentals. They be it OOPS, object-oriented programming, be it operating system, be it networking, they'll test what have you learned in the last 4 years of your engineering life, uh, and how long, like. yeah, what you have learned in the last 4 years in your engineering, and whether you have learned it correctly, because that's what the whole curriculum is about. Going to teach us, it's going to teach you like all the fundamentals, but most of us most of us, always look at the shiny frameworks and stuff and forget about the basics. So know your roots and get good at fundamentals, because you are going to get tested at the end of the third year or fourth year. So have you got motivated to learn networking? So okay. So the thing is, because I'm not exact, because I'm in full screen, so am I? I'll be, asking frequently whether I'm audible or my screen is being presented, which I'm going to do now. Is my screen audible and am I visible? Uh, yeah.
Yes. Yeah.
Okay. Sure. Okay. Okay. Sure. And yeah, because I'll be asking this very frequently. It's like, so please, yeah, answer like someone on the mic and answer. Sure. Okay. And okay, the what are we gonna do in the probably the next what's the time for the next 1 hour? We are left with only 1 hour. Okay. For the next 1.5 hours, I guess. Okay. We are going to understand how data flows through the internet, because the core principle of the internet is end-to-end connectivity. So whatever that's built on the internet, whatever that's done on the networking, is trying to solve how one guy from Chennai maybe is able to communicate with someone in California, like maybe your cousin in California, something like that. But the whole thing that the internet is trying to solve is this end-to-end connectivity. So if you are able to understand this end-to-end connectivity, you probably would have understood. By the time you have understood how this whole thing works, you have also mastered, not mastered, at least understood how the internet work in general, and also grasp a lot of how the thing works and the core concepts that build the whole internet. So you must be like, the only thing you have to know is how the data moves from one part to the other part. And if you are able to answer this, you have understood internet. So that's what we are trying to understand in this presentation. And the second thing is, this whole presentation is structured. This whole presentation is structured as a set of questions. While trying to answer those questions, we'll be either answering those questions or coming up with more questions. So it's like the question first approach. You'll be trying to ask some questions, same way how first principle thinking works. You'll try answering those questions, and then you will answer those questions or come up with more questions. And the second thing is, finally, we'll be understanding something called OSI model, which is a conceptual model which let us understand how this whole thing works. Like, I mean, how the whole communication in the internet works. I myself don't understand OSI model better, so this is going to be an experiment only, because I have created only few slides will be based on OSI model. So how people usually teach OSI model is, they'll first teach those, because it's a very theoretical concept. You'll be first presented with the concepts of the OSI model, and then you will eventually try understanding the theory behind it. But we are going to do the reverse. We are going to answer those questions, and then we'll be mapping it with the OSI model. As I've already told, I myself, because OSI model is very conceptual, and it actually requires a lot of guessing, because there is not any single uh, thing like this is how this works, like this is how this layer works. There are like many meanings derived by different people. Okay, there are many meanings given by different people. So I might be wrong. So if something seems off, that's why I'm saying, if something seems off, or what this guy is talking about, if you are getting this feeling, then please please turn on your mic and ask the question, or you can post in the thread, like, sorry, chat, and one of the hosts will forward it to me, like, yeah. And yeah, that's all. Because that's all. So let's get started because we are just looking at the curriculum now. Let's get started. So with some very trivial questions because actually will the how the structure of the talk itself is made us you will be gradually increasing the complexity. First, many of the questions will be looking very trivial, and also one more thing: if you find some vocabularies, if you are finding some term very complex, you can also ping in the chat because I might not realize that it's actually complex. Okay, so one more checkpoint is my am I audible? Like, is my
Yes.
okay? Sure. Okay, fine. And okay. Okay, this is the first question actually. So the question is why some sites are accessible across the internet and some are not. Uh, it's like you guys must have run some local application, right, in your local, be it running a React application or be it a backend server. You must have run something that ran on your local, that is running in your local host. There is something called localhost colon 420, whatever port it is. You might like it might be running in your local. But how could you share this? How could you share this? Have you ever thought how could I share this particular thing that's running in my local laptop to something to my friend? How can I share this to my colleague or how can I share this with someone else? If the question, if the answer just crosses your mind, something like hosting, uh, we'll come to it. But that's the question. That's the question I'm actually trying to ask. Uh, how can you do this? Like the question of how can you host something in your local host to your friends? Because how Google is visible. Like you open your browser and you are typing google.com. How uh, hello? Uh, okay, someone is asking something. Okay, fine. Okay, so how google.com is discoverable from your browser? How you are able to type google.com and you are somehow get something in your page, and how everyone is able to see google.com, but how you are only able to see your local application only in your local. Maybe there's a good reason why it's called local, but this is just a very trivial question. But uh, the thing is the thing that we are trying to ask is what makes Google something called discoverable? Why is Google discoverable across, and why your website is not? The first question. And the second thing is this is sort of a supplementary question because none of us like I myself have never bothered to understand what does this term. But one question is, have you guys, like you guys must have heard about this term, right, called local host. uh, if you have not, whenever you try running something on your local, this is what that showed in your browser: localhost colon 4200, which is, I believe most of you guys must have seen this already because, uh, like, I'm not sure because the future of Odyssey is resting in your hands, and probably all of you are at second year. So I'm hoping that you guys have already seen this fancy term called localhost, and we are just trying to understand what does this thing mean. What does the term localhost means? Or okay, so before understanding this, we have to understand some core things. Some core things means like what does IP address means, and we are not going to dive into the technicalities now, but let me just give you some facts, like some high level overview of what does the term IP address means. IP address is actually your address on the internet. So same as how if you want to send a post in your post to someone, you have to have an address. People also send it anonymously, but let's assume in an ideal world, you have to fill both the from and to part. And the thing is, the same thing with the analogy of sending post in the internet and the address of the internet, the address of the internet, the address on the internet is something called IP address. So when someone says when a device is connected to the internet, it must have this thing called IP address. So everyone, so it's not possible to connect to the internet using without something called IP address. And these are facts. I'm trying to say some facts. We'll look into the technicalities. I'm just registering some facts about IP addresses. Like every device that's connected to the internet should have an IP address, but one of the other facts is they need not be something called public. IP address need not be public. And what does the word public means and what does a public IP address means, we are not sure. But just register it in your mind and assume that it's a one mark question. IP address need not be public. And another fact is a device in the internet becomes discoverable when it has a public IP address. So these are some of the three facts which I'm telling you now. If you know about something called deductive reasoning, so deductive reasoning is like saying every all mammals have lungs, dolphins are mammals, so mammals have lungs. Sorry, dolphins have lungs. So the same thing we are trying to apply here. A device become discoverable when its IP address is public. In the last slide we have seen Google is somehow discoverable. So we can assume a fact that Google's IP address is public. We are not sure what does being public means and why every device in the internet has to have an IP address and what does the word even discoverable means, like apart from being visible on the browser. But these are the facts. And using this hypothesis or like this premises, we got into this conclusion saying that Google is somehow discoverable. And Google's IP address is public. So the thing is, but how to get the IP address of Google? So how do you get the IP address of Google? So because we are not sure, like we just understood like Google must be having an IP address because every device in the internet should be having an IP address. Google should also be running on a device. That's another thing. Google is an application similar to how your application is running in your local. Google should also be running in an application, maybe a powerful server or something, but still it's a device. But the device's IP is discoverable. So Google should also be having an IP address. So how do we figure out the IP address of Google? So there are certain ways to figure out. One of the ways is if you're on Windows, you'll just do ns lookup google.com. In your Mac, you just do host google.com. So whenever I'm putting when I'm typing this host google.com, it gives me the IP address of Google. In this case, you are getting the IP address of Google. And we'll come to it what does IPv6 means and forget about the last line because it's sort of out of the syllabus something. But one thing one thing we are getting on here is you have an IP address which you are going to use. You got the IP address. So what can you do with this IP address? That's another question. So I've recorded a video. Is it actually visible? Okay, the video is actually running. So I'm taking the IP address of Google and I'm pasting it on browser. And you can see that here you can see actually using the IP address itself will lead you to the actual website. So can you that means is the IP address and google.com both synonymous? Yeah, actually it is. It's like calling. You must have also be assigned a roll number, right? In your college or something. You might have an Aadhaar number or something. It's actually, let's say, how would you feel if someone is calling you with 180701219? Can you are you ready for the lunch? Like something. It's like asking. It's very hard to remember the numbers because, sorry, it's like, as I've told, IP address is the address of the internet. When you send someone, when you ask the browser, can you go to google.com? The browser have no clue. Like, or the internet itself doesn't have any clue where to go and look for google.com. It has to have the IP address. So behind the scenes, the same thing must have happened. The browser must have resolved google.com and got the IP address and must have sent the request to the IP address, not to google.com. Uh, and this thing, the thing that maps the domain name to the IP address is something called,
DNS.
yeah, correct. It's called DNS. So the full form is domain name system. So what's so fancy about it? Like, because it seems a very simple concept, right? Because if you look at DNS, it's nothing but you can visualize it as some sort of table. You have a table that just have two columns that says domain name and IP address. And you just have domain name and IP address, and you will just have for google.com, go to this IP address. As simple as that. But the thing is, domain names is the domain name, the DNS server. This is one more thing. Like, it's this is the concept. So before the internet doesn't know about google.com, it has to speak in terms of IP address. And DNS is the guy who helps in resolving the IP address, the domain name to the IP address. But uh, that's what I thought of. Just just introduce the concept DNS and move on. But uh, 30 minutes, like right before the talk, I realized I should at least give some sort of architecture on how the DNS work, because this is one of the very important question that interviewer asks, because they'll tell you, do you know how DNS works? And can you design a DNS? Because if you look at the scale, right? If you look at the scale in which DNS lookup is made, because for every call, if the browser has to resolve DNS, because you are making thousands of calls, if every time the server has to sit and resolve, okay, what's the IP for this domain, what's the IP address for this domain, what's the IP address? It's going to be very costly. So the system itself has to be very optimized on resolving it. So the infrastructure behind the DNS, I thought of, okay, let's add it to some extent and give a very brief overview so that when you are preparing for your interview, it will be pretty easy for you to, because it will give you that deja vu moment. Yeah, I've read this before, I've seen this before. So I'll be showing you something that uh, this is the architecture behind domain name system. Let me just finish it very fast, because how the flow works actually. You type in your browser like what is like google.com. So what your browser does is your browser checks in its local cache. When I mean cache, like we'll come to what does cache means, but you can assume that it's some local storage. Your browser checks whether uh, google.com, whether I've already resolved google.com, so that I doesn't have to go back and check it on some remote server. So if it's not finding the google.com, then it asks your ISP, which is your internet service provider. You will ask your ISP, which has something called a DNS resolver, which is what your browser asks. Your browser asks the ISP's DNS resolver, what can you tell me what is the IP address of this domain? And your this same caching, your ISP might have also already resolved it, because someone might have already accessed google.com. So there's already an entry that's stored in the ISP's DNS resolver's local cache. So if it's not even present in the DNS resolver, it goes to something called a DNS root server. DNS root server, which is 13 servers. Like there are only 13 servers globally across the world, which are nothing but actually there are 600 servers, but assume that there are only 13 IP addresses of this root server. So when your ISP pings one of these root servers, can you give me the IP address of google.com? And what your root server does is your root server, depending upon the suffix, the extension .com, .in, it forwards it to the next level, which is top level domain server, which is the TLD server. It asks the TLD server, like if it's .com, it goes to the DNS server of .com and TLD server of .com, and then in your TLD server only, because you can look at the amount of websites, right? If everything is being stored as a single big table, think about the think about the load, because I didn't look into the statistic, but there should be at least millions and millions of websites, and if it's a single lookup, it's going to be very heavy. That's why they have created this structure. They have segregated it into this structure. So first, it goes into the .com TLD, top level domain server, and the TLD server knows for Google.com what something called, like, it knows, because for Google.com this is where the record is being stored. It also forwards it to some server that's underneath it, which we call as authoritative name server. Uh, the authoritative name server is the guy who actually has the record, like who actually has the DNS record, who actually has the mapping from, okay, for this IP address, for this domain, this is the IP address. So there can be, because for google.com, I might be using some different authoritative name server. Like, I could explain actually what does authoritative name server means, but it might take more time, because, so I'm just saying, let's just visualize something, that authoritative name servers or where the actual records are being stored. The authoritative name server is the guy who actually hold the record of this mapping, google.com to the IP address. And this is the structure of the DNS server. So, like, this is because this is a very important, like, sort of very sought after question in interviews, because the idea of even segregating this or dissecting this into a tree itself is it's a very good DSA problem, because you have to choose this tree data structure instead of using some other data like hash map. Why not hash map or something else? Because this reduces the load, and you can read more about what is this authoritative name server, and there are different DNS records. It's not like there are different records like A records, triple like 4A records, and CNAME, and all these stuffs are there. And we are not going to go in depth of this. Maybe if we get time, we can look into it. But this is the concepts. Like, it's not as simple as you have a big table and you just map the domain name to the IP address. There is this big thing that is happening behind the scenes. So, like, and it forwards the IP address back, like, to your DNS resolver, and your DNS resolver give it back to your browser, and it gets cached at every layer. Cached when, like, one more thing, when I mean cache, is right, cache, assume that caching is a way of writing, let's say you have a to-do list in your phone, and you can also write it in your hand itself, like the to-dos in your hand itself. So whenever you want, or like, not even to-dos, let's say your mom asked you to go and buy some groceries or something, and she sent it to you on WhatsApp, but you're too lazy to open your WhatsApp and stuff, so you have written it on your hand itself. But the thing is, so opening your phone is a pretty costly process, because you have to turn it on, you have to go to WhatsApp and open WhatsApp and all those stuff. But if it's in your mobile, if it's in your hand, it's very easy. You can easily see it on your hand. So that's what caching means. Caching moves the data pretty close to your physical location, or so that it's very easy to do the lookup. But the issue with caching is it might get out of date. What if your mom also sent one more list of vegetables, like, or something? Now your cache is out of date. Now you are going to go back home without buying that one additional thing, and you're going to get scolded, or who knows, maybe beaten. But it's yeah, like, caches get maybe expired, caches get invalid soon. That's what happens in DNS. Like you might have seen it in your browser itself. You might be trying to access some website. It might be showing something like, uh, let's say, I have hosted a website on some IP address and I've associated this IP address with a domain name. And suddenly, what I did was I changed this IP address to something else, but your local browser also caches it, right? I was telling you. Now your browser might be saying that this website, google.com, is being hosted on this IP address, but the person who might be hosting google.com might have changed the IP address to something else. And it's actually available in this DNS server, like this authoritative name server. But your browser might still be pointing to the old IP address. So it might be, you might be trying to open google.com. It might be saying that page doesn't exist, because what it's doing is it's trying to resolve google.com and it's trying to go to the IP address, old IP address. So it might be going to the wrong IP address. So that's why uh, caches might get expired, like might get invalid always. So that's why it's important to always, it gets refreshed at some point, like 2 days or like 3 hours or something. It depends on the browser, but it might get wrong, like it might be showing having invalid data. That's why people tell go and clear cache, it will start working. That's what exactly is happening when a browser when a browser is not reachable. You might have to clear the cache so that it also clears your DNS cache. So now your browser, it will be a cache miss, something called, because the DNS entry for google.com is not present in your browser. So what it does is it goes to the ISP, and if you are very unlucky person, probably your ISP might also be using the old cache. So if it's happening at the ISP level, when I mean ISP, it's your Hathaway or Airtel or Geo. That's what when I mean by ISP, your internet service provider. It's very unfortunate because you can't do anything. You can't go and clear cache at your ISP. There are workarounds for it. You can change the names over and stuff, but yeah, you will be unfortunate because the cache there itself is invalid. So that's why. But now you know DNS. If you know the actual IP address of google.com itself, you can still access google.com. You don't have to rely on DNS. You can just go and type in your browser the exact IP address, and you will be redirected to the browser, isn't it? Like, think about it. Like now you are bypassing, you are just hacking into the system. You are telling, okay, I know my stuff. Like I know my DNS and my ISP is doing some stupid caching. So let me do it on my own. Like you will just copy the like you just know the IP address. You will directly go to the website. Now you can see your favorite website, like, without using DNS. So that's what. That's one thing. Like that's one thing I wanted to say. Like this DNS thing, and I hope you are clear. And okay, okay. There's this thing. Uh, you might be wondering what does it mean? There's no place like dash. It should be home, right? 127.0.0.1 is home, like actually. And the initial question, I was asking, what is a local host? Like in this case, local host means 127.0.0.1, but we have not answered the first question itself, like what makes Google discoverable. But I'll come to it. But I don't know why I pasted this slide here, but maybe never mind. But let me explain it also. It's like when you type local host, right? To give a very good analogy, let's take the postman itself. Like a postman is coming to your house and you have to give your letter to him. You are writing your from address as, let's say, your IP address. And instead of writing your same IP address again, what you do is you write something like to myself. Localhost is something very similar. Instead of writing from your address to your address, which is pretty same, instead you are doing from your address to myself, which is what localhost is. Localhost is loop back at this. So whenever the postman sees the letter and he sees, okay, from this to myself, and what the postman does is first he'll give you a weird look, but what he does is he'll just not go and post it in the post office, which which he does will eventually come back to you only. But what he does is he'll not even go to the post office and post it. What he does is he'll just look at the post letter and will just hand it over directly to you. And this is what exactly your OS does when it sees localhost. And in the case, your postman is your OS. And whenever it sees the destination IP as localhost, which is 127.0.0.1, it just hands it back directly to you instead of it sending it out in the network, which will somehow eventually come to you because you have given your address only. But using localhost, you can prevent it. Your OS just looks at it and just give it back to you. So when someone asks you what does localhost means, like you can just tell it's just to myself, like it's just writing the destination as myself, not the exact IP or like not the exact address. It's like saying to myself. I hope you're clear on this subject. And the second thing is, I guess we have not still answered the question of what makes Google discoverable. So, and this is a question I guess we can answer eventually. But if you guys are aware of how a website is hosted, so I also I'm not going into the depth of it, but this is also let's understand how we understood DNS. Let's go through a flow of it, like how thing. Like one more thing is my pace okay. Am I going very fast? Like, or I should slow down? Hello,
Yeah,
or it's fine, right?
yeah.
Okay. Okay. So the thing is, yeah, we coming back to what we were saying before. Let's understand how a website is hosted the same way how we understood how DNS work by just understanding how the data flow, like how the process happens. So the thing is, let's say I want to host google.com. Let's say I'm Larry Page. No, not like that, but let's say I own google.com and I want to host uh, google.com. I want to make it public. So I'm trying to answer the question how google.com went public, how google.com becomes discoverable. So that's what I'm trying to answer here. So the hosting process looks something like first, I want two things. I will be approaching, I want to have a name for my website. I don't like my website being called 172.168. This is this. And I want a good name for my website, which is google.com. So what I'll do is I'll go to some domain registrar like GoDaddy. Let's say I'll go to him, which I'll go to GoDaddy or yeah, I'll literally go to that. Like, yeah, like fine. I go to GoDaddy and I'll just ask, okay, do you have the domain name do you have the domain name called google.com? So because I have to ask this question, otherwise it's like selling the same land to people, which is very common in the current world and but in the real world. But what happens is registrar like GoDaddy actually have to check whether this land is being registered on some other's name. So it actually asks this top level domain server only. It asks this registry, is google.com already registered? If there is a record in this thing, then what happens is your GoDaddy will say, sorry, sir, we don't have google.com. Can you use yahoo.com? Like they won't ask it, but they'll say, okay, we don't have this domain name. We don't have this domain name. They'll come and tell you this particular thing. Uh, So you can either choose a different domain name or you can just choose to host it on the same IP address itself. But let's assume that they are saying, okay, this is available. Your google.com is available. So what you'll do is you will just pay for the domain and you will just have to renew it on some annual basis or monthly basis, so and so like that. There's a business model around it, and different domain registrar charge different money. Uh, yeah, but let's assume that you got the domain name, and now you have the domain name, and but your website is not hosted anywhere because so what you do is you got the domain name, and GoDaddy itself provides something called hosting service. So first we were looking at the domain registry service of GoDaddy.com from which we bought the domain name. And then there is another service which you can get from GoDaddy. There are many guys who can provide this service, but let's say you look at them and you will ask, okay, get the like what you do is you give the bundle. You let's say you are trying to host let's say google.com is written in React, and you will give the single JavaScript bundle, which is let's say you have the bundle. When I mean bundle, let's say it's some big JavaScript code, or like you give them everything that is required, and you will just give this big thing like this big JS bundle, and you will also tell them this is how to run it. Like you will just have to call this, just you have to run this. Let's say if it's a node server, you will just have to call node index.js, whatever the entry point is. Let's say I have a bundle, and I'll just also tell them this is how you run it. So what they'll do is try, they'll run it on their server, which has a public address, which they run it on a server or some computer they have, and which has a public address. Now you can access your uh, website by just hitting that IP address. Now your website is actually officially hosted. Like that's what this process of hosting means. You somehow found a device which has a public address and you are somehow running it. Like you are able to just go to that IP address and now it's somehow visible. That's what hosting service does for you. They just get your code and they just run it somewhere, some on some device which is visible across the internet. The thing is now it's visible. But the thing is, you somehow have to associate this IP address with your domain name. And GoDaddy itself provides some DNS setting where they let you create a DNS record where it's just a single button click. You will just associate for the domain which I bought. This is the IP address. From where you are getting the IP address, you are getting an IP address from a hosting platform. From where you are getting this domain name from a register service from the domain register. And in this case, GoDaddy is the guy who provides both the service. But it can be like you can be hosting your thing. You can be hosting your application in your local itself. Yeah, you can host your application in your my local laptop itself, and I can associate it. Uh, I can associate my local IP, like not local IP, but my IP, my laptop's IP somehow with the domain name. But in this case, I'm getting the IP address given by the hosting platform with the guy from the domain name. So sorry, domain registry platform. And it just creates a DNS record, which is just this keyword, like which is just this domain name and IP address, and it just send it to the DNS server. Now anyone can access your website by just sending, by just accessing the google.com or like whatever your domain name is. But the thing is, it will take 48 to some hours, but it's also another thing. But now you know how a website becomes discoverable, how a website goes public officially. That's what we have seen. I guess we have answered the question of. I guess we have answered the question of. Okay, wait, let me go back. Like, what makes Google discoverable? You just host it. You will just create a DNS record. Now Google is discoverable. And the second question is what is a local host, which is just a host to yourself. Local host is a loopback address, and it's like writing me in the to, myself in the to section of your letter. So I guess this is clear. We have answered two questions, which is very trivial, but at least we have looked at how DNS works, how to host a website, how to create a DNS entry, which could be a practical session, but like, yeah, we don't have time actually. I think we are pretty much running out of it. Like, okay, let me go fast a little bit. And the second thing is, we also now I just want you guys to do some role play because I'm supposed to show a live demo of it, but I later only realized, but there are some limitations in my company provided laptop, so I can't do it like I can show it hands on. So let's assume I'll be asking you this question. I should have been asking you this question given my IP address because we have seen that you have an IP address. If you have an IP address, you can just put it on your browser and it goes somehow hit the google.com. So is it okay if I give you my IP address, will you be able to access my application? We still don't know whether my IP address is public because only if it's public, then you'll be able to see it. Then the script was I would be giving you the IP address. I'll be posting it on the chat. Then you will be replying me back saying that no, like then I'll be then I'll be saying no, right? Like something like that. But it's not happening. So just play along with me. Like you'll be saying no, right? Yeah, because you'll not be able to see it. The actually it will be giving the your browser will be saying timeout. The website that you're trying to access is not reachable. Then that I would have shown you my mobile. And actually, if I put IP address of my mobile, IP address of my laptop in the mobile, it should be visible. It should have opened my website, like because I don't know why, but it is possible because that's the script. I should have shown you. Just believe me in this case because I just had to put my IP address in my mobile, and actually, I you could have seen my local host, like whatever application that's running in my local, exactly in my mobile, with using my IP address. So the question here is how how my mobile is able to access my website which is running in my local, while none of you can't. Because if it's available in my mobile, then what's exactly stopping you from seeing it? So this is the question that we are trying to unveil. Like uh, to, before that, we have to understand something called different types of network. Because let's go fast because I guess we are running out of time. So yeah, like there are first we have to understand something called first we have to understand that internet is not the only network. There are different types of network. So the same example, I'm in Chennai, I want to contact my cousin in California. Like one thing, I don't have any cousin in California. It's uh, just like that. Okay. I want to contact my cousin in California. So the thing is, somehow, I don't know, we are connected. Otherwise, we won't be able to even message. Like, let's say, connect. Like, I'm making a video call to him. Somehow, because internet is not magic, there are many intermediary devices that somehow connecting both of us. It can be an underground cable, or it can be some satellite fancy stuff or something, or it can be just a wire as big as like, which is like stupid, but like let's say we have created a wire of 14,000 kilometer and somehow we are just speaking via the same cable, like one-to-one connection. Somehow we are connected. That's what the distance when the kilometer is going below, like beyond some 100 kilometers or something, we call it internet. We call it internet when it depends on the range. When when the range is so big, we call it WAN, which is wide area network. And when the kilometer is little bit small, which let's say your city size, then it's called MAN. And when it's just your size of college or your office, then it's called LAN. So a man is composed of multiple mans, and a man is composed of multiple lands. So this is how the whole internet itself is made. So so I mean the internet is not some magic, like you will just say like you'll just do some, you just take your wand and you just say I want, like something like, I forgot the spell, but yeah, fine. You will just wipe, like you just do something with your wand and somehow the message gets delivered. No, there are many intermediary connections that some you are somehow connected or with different devices that make the whole communication possible. That's what that's what like the major reason why I'm telling you all this is to get rid of the assumption that internet is the only network. There are many networks because even in your college, right, we are able to access some only few websites. Sorry, not few website. You should be able to access some website or some IP address only within the premise of the college. So those are LANs. So those are LANs. Those are actually LANs. Once you get out of the college Wi-Fi, that's why to even connect to that particular IP address, you first have to connect to your college Wi-Fi because you can't access it using your mobile network. You have to switch to college Wi-Fi, which I think is slower than 2G, but let's fine. But somehow you have to connect to the college Wi-Fi in order to access the IP address, in order to access the website, because it somehow is creating a LAN, uh, and your Wi-Fi is a portal to the LAN. So only if you are connected to the Wi-Fi, you are connected to the website that is hosted within your college. Are you like trying to get the image of what I'm trying to get at? Like somehow, like uh, okay, so the same thing with metropolitan area network, like all the things. There are also citywide some services which are only available if you get connected to the city Wi-Fi. Uh, all those things because somehow they are letting you into some network which may not be accessible if you are accessing it from other internet, like other network, which can be your mobile data or something. So this is just to give you a brief overview of just making you understand that internet is not the only network and how the internet is not something magical. Somehow you are connected by something in the middle. I am suppose, yeah, like this is what I was telling you before. Every device that's connected to internet has an IP address. This is an exact slide which I showed you, I think 10 slides back. But I'm going to make a little bit change to this. I'm going to change it like every device that's connected to a network has an IP address. It's not internet, it's a network. So every device that's connected to a LAN will be having an IP address. Every device that's connected within the man will be having a network, not only the internet. So even though it's what's the full form of IP? It's Internet Protocol, right? So it doesn't only belong to the internet; it also belongs to any network. So every device that's belong to a network should have an IP address, will have an IP address. So, but why? Like, but when I say this is one more thing, like because now we are getting into some technicalities. Let's okay. So there is this thing called IPv4. When you say an IP address which has a fixed length, which is 32-bit length. So with 32-bit length, you can support only 4.3 billion addresses. But if you look at the world population, it's almost double. It's 8 billion. And if you just consider everyone having some smartwatch, or like let's say 5 IoT devices, it's going to get 5 times big. So in the initial days, people have not thought about IoT. They have never anticipated the population will grow this much, which I'm not sure like why they have not considered, but yeah, they have created it with 32-bit, which supports only 4.3 billion. But there is also one more thing. So this actually shows us how limited IPv4 is. It will be exhausted very, like it should have been exhausted already because when the internet service provider like is allocating, they are trying to make every device that's connected to the internet public, then they don't have the IP address for doing so, because it's only 4.3 billion. And but there is also another thing called the IPv6, which is 128-bit, which the engineers like after realizing these truths about IoT and population growth, they have made it 128-bit, which is I guess it will never be exhausted because think about it, it's like 340 and bazillion, which is like 3 followed by 38 zeros. So, which is never going to get, uh, which is never going to get exhausted. So, but the issue with IPv6 is the adoption rate of it is very less. Now, many legacy system which are running somewhere like they are still using IPv4, so we can't just say okay, let's make everyone go public, let's assign everyone some public address so that everyone can access everyone from anywhere, because if we are having IPv6 and ISPs can literally make it possible, like they can just make everyone go public, which is the core principles of the internet, like end-to-end connectivity, anyone can talk with anyone. But the issue is the adoption rate is less, and also there are few issues with it. So still we'll be relying on IPv4. So that's why some IP addresses are private. Uh, like some website, like some IP address we were discussing before, or public, google.com or public, but there are some IP addresses are private. The IP address which I should have shared you, uh, which I should have shared you on the chat, like my IP address, I should have shared you that IP address. The reason why you are not able to access that IP address is because it's private. It's not accessible to people outside my network. Consider your LAN as a fort, like a wall surrounded. People can still be inside this wall, like they can still be devices that can speak with each other. That's what I'm getting at, because maybe I have already given you some spoiler, but yeah, assume that your LAN has some big wall, and like a very big wall. Maybe if you're familiar with Attack on Titan, that's a very cool anime. They have a big wall surrounding the whole town, maybe three walls, yeah. But in this case, let's assume that your land is a very big wall surrounding a lot of houses in the middle, and consider those houses are devices, and those devices can, people like those devices can still access each other because they are inside the wall. And but to go outside of the wall, there is something called a golden gate. Can be several golden gate, but at least one land should have one golden gate. One fort should have one golden gate, which is like a gateway to the outside world. There can also be wooden gates, which are the gate, which are the doors of the houses present uh, in the middle of this fort. So what I'm getting at is, consider the analogy is the golden gateway. The golden gate is your public IP. Your wooden gate, which every devices inside the fort has, is the wooden, is the private IP. Like golden gate, public IP, uh, wooden gate, private IP. And to go for the people, for the devices living inside the land, for living inside the fort, if they have to go outside of the network, they have to go via this golden gate. So this is the analogy that sort of explains the whole land, and we'll try to, this is the whole analogy, but we'll try to understand the whole internet by using this analogy, plus add some technicalities, some technical terms to it. Then like that's what the next slide should be explaining you. So this is what, like, if you have understood the analogy, yeah, let's move on. Like you have understood it, right? Like because I think too much repetition. It's I'm just okay. Let's. But one more question I have, like, but then how those devices access the internet? Like, because you can well ask. I have already told you the spoiler, I guess, because if you want to go to the outside world, which is the internet, you have to go via the Golden Gate. But think about it, like because you have to go via the Golden Gate. But if someone is sending you something, uh, it's like will come to it. But this is one of the questions that you have to keep in your mind. Some IP address lives within the fort, but how can they go outside of the internet? I know it's via the Golden Gate. Hello, yeah.
Web server and reverse proxy.
Hello, yeah. Hello.
Two web server and reverse proxy.
You are actually not audible. 1 minute. Like,
Two
uh,
web server and a reverse proxy, right?
yeah, reverse. Like, but if you look at it, right, even you don't have to have a reverse proxy because, like, probably you can say your router is acting as a
Yes.
proxy plus a reverse proxy. Yeah, but like, yeah, we'll come to it. Like, but for now, yeah, that's a very good observation actually. But think about it. You have set of private IP addresses and you have to access the internet. Now the question is how, yeah, like how those devices access the internet. Uh, so yeah, let's move forward. Okay. So I have all like if I've already given a lot of spoiler. The major reason why my laptop and my mobile are able to speak with each other is they are connected. They are on the same network, which is being established by connecting to the Wi-Fi. So the whole fort is being made by the Wi-Fi network, and all the thing that is connected to the Wi-Fi, all the houses which is inside the Wi-Fi is called all the people who are inside the Wi-Fi, my laptop and mobile are actually literally residing inside the fort, which is being made by my Wi-Fi. So that's why they are able to access it. They are able to even discover it. Like the discoverability is the issue here because people outside the fort won't be even able to know there is a guy called my laptop that's running. But my mobile is just able to discover my laptop, and that's what that made the whole process uh, possible. So, so this is one thing that I wanted to tell you. Like, yeah. Uh, so we are trying to answer this question of how my mobile is able to access my laptop. The answer is they are connected to the same Wi-Fi, and but still we don't know how the whole process works. We just know as a fact that if two devices are on the same network, then they'll be able to find each other because uh, because in this case my laptop and mobile are on the same network, so they are able to find each other mutually. That we have answered our third question, which was the how my mobile was able to access my laptop. Yeah, because they're on the same uh, network. So the thing is, it's not peer to peer. Like I think my laptop is not directly connected with my mobile. It's not because you might have already seen there are many network topologies, like network topologies in the sense if this arrow you can see at the right side, right? If let's say if every device is connected with every device, then you can see it every device just can directly connect, like just can directly it can be like Ethernet wire, or you can just connect it using a USB cable or something. But yeah, like, I'm just saying that every device is not connected with every device. What it does is it connects to some common entity, and that entity, like uh, in this case, the entity is your router. So what I'll do is I have a Wi-Fi, and my mobile is not directly connected with my laptop. Both of them are connected or on the same Wi-Fi. So that's that's how like so every traffic, when I mean traffic, every data, like I want to forward some packet. Let's say I want to say a hi message to my to the let's say I have created a very cool chat application. What it does is it just let people on the same network communicate with each other. The issue here is it's not directly connected. What is happening is there is a middleman in this case. So there is this router first they have to connect to so that they can create the Wi-Fi network. So, I mean the LAN network. So in this case, every packet that every data that you're sending is forwarded via this router. So that's what make people to put some parental controls. They can literally listen to what thing you are like trying to access and all of those things, because wherever you go, you have to go via the router. So someone can actually put some sort of a packet sniffer or something, and they can just literally see all the traffic that's going in your router. Uh, so there's a middleman. That's what I wanted you to understand. Like there's a middleman called router. In your case, it's the modem. Like it's whatever you have bought from your ISP. Whenever uh, you want internet, the people from Hathaway or Airtel come to your home and they set up this modem, and they are actually creating something called a router with which you can connect to the internet. So in this case, they are creating the central entity. But in this case, will be a switch or a hub or something. Will come to it later, but just assume that when devices are connected, when I mean that devices are connected on the same LAN, the topology is this. It's called star topology. It's like there is a central entity where every traffic is going forward, and this is what it is like. This is a star topology. Whenever I mean LAN, I mean star topology. There is a middleman who is listening or forwarding whatever that's happening. And moving forward, okay, we have looked at LAN from the perspective of a very analogous way. Like we are saying Attack on Titan, we are just saying Postman, this, that, but we have to understand the technical terms behind it also, right? We can't just go and tell the interviewer, like, yeah, it's Attack on Titan, the big foot, that they'll be like, okay, that's what we are getting into some technicalities, a little bit of the technicalities. Let's zoom into LAN, how a LAN works, how devices within a LAN communicate. So before understanding it, I have to, okay, we only have 30 minutes. Okay, let me sort of fast forward it. Every device has something called whenever you are connecting to Wi-Fi, whenever you are connecting to a Ethernet, let's say many of your devices might not have the Ethernet port, which you can. There are several ways to connect to the internet or the network itself. Be it if it's a wired way, the most preferred way is Ethernet, and if it's wireless, you have to go via like that's why Wi-Fi, or you can also use this USB, this dongles and all. So the hardware that lets you connect to the internet or like to connect you to a network is called NIC, Network Interface Cards. So every device that wants to be a participant of some network has to have this device called NIC, called Network Interface Card. Currently, your mobile also has an NIC card. Your laptop might have Ethernet NIC, or it might not have, but it should be having a wired NIC because that's the common pattern now. Like everyone are having Wi-Fi. So I just want you to understand this is the hardware that makes it possible for you to connect to the internet, like for the network in general. I'll be very clear in using the word network and internet. Okay, we have seen this. And the second thing is, as I've told you, like IP address is the network, like IP address is the address of the internet. So, but there is one more thing called MAC address, which is your address of that NIC, which is making sure you are able to connect to the internet. So every device, every NIC device has a unique MAC address. So it's a 48-bit address, and the first 24 digits are organizationally like the manufacturer. It depends on manufacturer. For Intel, it might be something different. Intel has a set of OUI, like organizationally unique identifier, and the rest of the 24 bits are like the rest of the 24 bits are device specific. For Intel, let's say for the first device they have created it 01. For the second devices, it could be 02 and stuff. So This is the structure of media access, the MAC address. So I want you to understand there is a MAC address which is globally unique, which every like all of your NIC card will be having. Your NIC decides what MAC address you have. So, and another thing is we are just trying to understand how the LAN works because it's, oh my, okay. So we are just trying to understand how LAN works because we have not seen how the switching, like how the sending of packet is being done. Let's say there is this intermediate guy called switch. What he does is, let's say he's the guy who's going to forward your traffic. Let's say, let's forget about the internet. Let's say power cut happened. So the only possible way is, okay, still you won't be able to access the LAN itself because switch itself requires power. But somehow, let's say you, your switch has access to electricity and your computer also, your router doesn't have electricity. So you only can access your LAN. And there is this, let's forget about internet in general. You have this intermediate guy. Now let's say in the next frame, the computer A wants to talk with computer B. So assume that it knows the address A and address B. So what is like what how this whole thing happens is you will just tell the switch that, hey dude, like I have to communicate the computer with MAC address B. So will what the switch does is the switch has an address table. The switch doesn't know because switch has several ports like one, two, three. It can have multiple ports. In the first port, let's say computer A is connected. In the second port, computer B is connected. Computer C is connected, but the switch doesn't know. The address table is empty. So only when the computer A sends the request, it knows, okay, from port one, actually computer A is connected. So the switch learns, the switch tries to fill the address table. In this case, the switch doesn't know where the MAC address BB is present. In this case, what it does is it just floods it across all the ports, excluding one because that's where the request came from. So it just floods it to all the other ports, two and three. Now the thing is, the computer C also get the packet. Now let's say you are sending computer like, hey, let's bunk the class tomorrow, something like that. Now both computer C and computer B both will be getting the message. But the thing would be only computer B will be sending the message back because that's what the message is intended for. But let's say by mistake, computer C, your professor is using and he somehow, because he can also receive the message, then you'll be in trouble. But the idea here is the switch is a system uh, that learns like by just flooding. This concept of flooding, it just broadcasts it to everyone when it doesn't know where a computer is present. Like in this case, computer B only responds back. In this case, MAC address, your switch just fills on port number two on the interface two. Computer B is present. So this is how the whole switching thing is done. So in this case, until like it keeps on broadcasting. If let's say someone just plugs 3 to 1 and just changes this thing, so this is going to be an issue because someone might because let's say someone just changes the port 1 and 2. Now the message intended for B is going to A, but the computer A will respond back with, okay, this message is not for me. The computer A can tell whenever it's getting the message, but your switch is going to think, okay, this is actually wrong. Like your switch is actually going to think, okay, computer B is present on port 2, but actually someone has changed and like just changed the port. This is going to be an issue, but I'm just saying. So this could happen in the internet, like in your local area network. And but if you look into it, right, I was saying like no one is going to know the IP addresses of people. Okay, 1 minute. No one, like in this case, you can see that the destination is B, the source is A. No one is going to know the MAC address of B. Probably what in the browser you will be typing the IP address of computer B, but the local private IP address of computer B. Okay, like the private address of the computer B. So in this case, how this, if you're typing the IP address of computer B, uh, because switch is a device that doesn't understand IP address. If you're going to ask the switch, can you forward this to 192 dot this, which is the IP address of computer B, but your switch is a device that operates on MAC address. So what it does is we have a protocol called address resolution protocol. What it does is it converts the private IP to your MAC address. So let's say I am every computer has something called an ARP cache, the same thing. Like knows that every computer knows that okay, in this local network it caches. Every computer knows okay, in this port uh, when I want to access this private IP, this is where I have to. This is the MAC address of it, so that you can send it, so that you can send that MAC address to the switch. But before doing that, like because how do you resolve it? How do you convert an IP address, private IP address, to a MAC address? So there's a protocol called address resolution protocol. So what you do is ask, you will just send it to the switch, same switch. Like you will just make a ARP request saying that it's literally asking who has the IP address 192.168. This. So the computer with that MAC address will respond back saying that, hey, I have the IP address and this is my MAC address. So now the computer A will just, okay, I got the MAC address. Now it caches it locally. So whenever it wants to talk with the same IP address, instead of making the same broadcasting signal again, it just takes it from the cache and just uses the MAC address itself. And this is the case actually. 1 minute. Yeah. So this is the actual case. Uh, but the thing is, this is why, because someone also can do MAC spoofing. So whenever someone is asking, hey, dude, like who has the MAC address 192 dot this. So if a professor at computers, he can literally say to understand how the students are talking, he can literally say, yeah, I am the guy. He can literally say that now the switch would be getting two guys, like two people saying, I am the MAC address. I'm not exactly sure how it's being handled, but let's say computer B is down, but computer C can literally say that I am the MAC address, which is of computers B. Now computer A will think, okay, this is the MAC address BBB. So you will start doing the chat without realizing you're talking with your professor and you'll be in trouble. So there are some issues with this, but this is how the LAN network works. Like, are you able to understand? Like, this is the switch is the guy who works on MAC address, and you just use this thing called ARP, which converts the local IP address to your MAC. And this whole conversation happens like this. And I also want you to understand the difficulties or like the danger, like this issues in these things. But there are certain mechanisms with which this switch can employ to prevent all this. But I'm not well versed with it. But that's a topic which you can experiment. But have you understood this thing? Like, this is how the communication within a LAN happens. So the next thing is, you must have got this question, like why use MAC address when you have something called an IP address? Uh, Sorry, why use IP address when you have, because the reason that we were using IP addresses, let's say MAC address I told you was 48 bits, which supports almost some trillion, like 280 some trillion amount of addresses. So it has considerably so much amount of address which can support the whole world, like exponential amount of it can support until some so long. I'm not exactly sure, but it has trillion addresses. So why don't use MAC address as the address of the internet? Because I also told every MAC address is unique, which is not the case with IP address. So your IP address is tend to change dynamically. So you can try noting this down. Now you are connected to your Wi-Fi with your Now you are connected to your home network or something. And so the next time you connect to your IP address, so it's possible that it will assign you a different IP address. So your IP address tend to change. Your private IP address, even the public ones, tend to change. This is called dynamic IP addresses. So IP address are tend to be dynamic. So if let's say IPv6, everything is dynamic, like even the public address, let's say are dynamic, assume, and I want to contact, it's like your mobile number itself is changing. Now I'm trying to call my friend, and later it's calling to someone else. So this is going to be an issue. So why? Like IP addresses are dynamic. Mac seems to be a better option, like because Mac doesn't change, it's unique. It is associated with a NIC, your network interface card, so it's not going to change anytime. And your IP address also has less addresses, and it also tends to change. And you like your router because your router might keep on changing your IP address dynamically. Because think about it, let's say you have your IP address, your router only supports only 10 people at a time. Let's say your connection limit is only 10 address your router supports, and 10 people are got connected initially to your IP address, to your router, and it got assigned address like 1, 2, 3, 4, 5, 10, and now they got disconnected from the internet, and now your router has actually ran out of the address, the private address itself, I'm saying. Now, other people, even though the 10 of the people, even 5 of the people are idle, they switched off the Wi Fi and just went somewhere else. Still, even though the IP address was statically assigned to people, you'll not be able to reuse the IP address because it's assigned to people itself. Already, it was assigned to people. Uh, so that's why IP address tend to be dynamic, so that whenever you disconnect from the internet, so actually the IP address which you are using before might get assigned to someone else also. So that's why IP address tend to be changing. But MAC address tend to not change. It also has humongous amount of capacity. Your IP address is not humongous. It's like MAC address literally is asking IP address, you don't deserve to be the address of the IP. Just visualize this. It's quite funny, but yeah, it's actually why a more deserving MAC address has not got the title, the address of the internet, when less deserving guy like IP address got the title. So if you yeah, this is what I was telling you. Okay, this is the next thing because MAC address, as you can see, it was like just random. So we'll look into it, but there are some good things about IPs and MAC address. It's called routing and subnets. This is the core reason why the whole internet uses IP address because MAC address is just random, but IP address has some logical structure to it. It's structured. So that's the main reason IP address is being used. So MAC address, even though it can cry as long as it wishes, but MAC address, even though it thinks that it's more deserving, but IP address, even though it is less deserving, it has some structure which makes routing and something called subnet possible. And we'll be looking at what does it mean in the upcoming slides. And we are running out of time. Okay, fine. Okay. Now I told you to forget about WAN, the World Area Wide Area Network. Now assume that you got the electricity back. Now you can access the internet. But now your question is how a device communicate with another device outside its local network. So you have a device which has only private IP, and how can it access another device which may be public, which should be public, uh, with a device like how can it access another device? Let's say in this case it's Google. How can it do that? We'll look into it, and this is called. Then we have to look into this thing. I think I've already given you the spoiler. This golden gate, which is called the default gateway. So this is your router. Typically in your home network, this is the only device that has access to the internet. Literally. Now, your laptop doesn't have access to the internet. Believe it or not, you cannot connect to the internet. Only your router can. So, if someone is if someone is preventing, if someone is putting uh, a barrier, if someone is blocking you or blacklisting you from your router, then you cannot access your router, which itself is enough to cut your whole access to the internet. So this is the golden gate. Your router is the typical golden gateway, sorry, default gateway. So which is your gateway to the internet. So let's look at it. So I was asking you like how it is possible. So that's where we were actually that's where the concept of proxies and reverse proxies comes into picture. But in this case, proxies and reverse proxies are this thing that happens at a web server level. But in this case of your local router, which also does something very similar, what it does is let's you have a router, and whenever you are sending a letter to your router, whenever you want to send a letter to the outside world, what your router does is it does something called network address translation. What it does is it somehow converts your private IP to a public IP, which is the public IP which is assigned to the router by the ISP. Whenever you are not, you are actually paying to your ISP because they have provided you with a public IP, which is your router, which is discoverable across the internet. So you are actually paying for the router, the public IP they have given you, which is enabling you to access the whole internet. So the thing is, whenever you're sending some request outside, as I've already told, your default gateway is the only guy who has access to the internet. So it does something called NAT, network address translation, which converts your private IP to your public IP. And let's see how this whole process happened, which I think is pretty cool. Like, actually, it's. Let's look into it. Let's assume that this is the left side is your LAN, and you have a router that's sitting in the middle, and you have a web server that's running somewhere, and you are just sending, you are putting, you can see, right, in source we are specifying our private IP. In the destination you are probably you are probably telling the IP address which you have resolved by using the DNS. In this case, let's assume that it's of Google only. Now you send, as I've already told, all the communication, be it within or outside, happens via this router. So you typically send this request to your router, and your router, what it does is it just gets these packets. Like, okay, this is the source, this is the destination, and then what your what your router does is like take a closer look at the source, which is being sent to the web server. What it does is it literally changes the source from your private IP to its public IP. But it's not only changing that, it also appending a port number to it. It's also literally saying colon 4500. And you might ask why, but let's look at how the web server respond back. Like, I just want to reiterate, your router has replaced the private IP with the public IP, but it also, for some reason which we don't know it also appended some colon 45, some port number, which is completely random. When the web server responds back, you can actually see the source is the destination. If you look at the destination, it's the exact. If you look at the request and response, it's actually the ulta. Like, now the source is the destination, but now the destination is the source. The reason being, just think about this scenario. How would, like, if let's say we are forgetting about the port number, what happens if multiple, my mobile is also making a request to google.com, my laptop is also making a request to google.com. If your NAT translation, if your router is just replacing the private IP with the public IP, then when the server responds back, the destination would just be saying the router's ID. how your router knows, okay, I have to give the response back to the laptop or back to the mobile. So what it does is, so you understand the problem, right? It even it can send. It's completely okay to send without any port number. Your source can just be uh, the public IP itself. But while getting the response back, now your router is confused. Like, whom should I send the response back? Should it broadcast? No, like the I don't want my like my search or like to go to other random person. But yeah, so what happens at this stage is your router also maintains a table. What it does is it as though it just picks a random port number and it picks a random port number and it just assigns whenever someone responds me back on this random port number, give the response back to give the response back to this guy, like to my laptop. So in this way, it creates something called I actually forgot the table's name, but it creates this table where it associates. Okay, for this random port number, for this port number, it picks in random. It picks the port number and it associates whenever someone is responding back me on 4500. This is the IP which you have to respond back. So in this way, multiple computers can make the request, and with the help of these port numbers, the response will be sent to the right device because you already have the mapping. The response, yeah. But there is one more issue because what if because like yeah, this is the typical response. Now uh, again, it's a vice versa thing because NAT, what it does is it again converts your public IP to private IP, and with the help of the port number mapping, which it has created while sending the request itself, it knows the source and it just maps it back and send it to the right device. But there's an issue with this. What if my laptop is making two requests at the same time? Now, let's say I have two tabs in my Chrome and I'm making two simultaneous requests. Now I'll be getting two responses, which has the same source and same destination. Because is it okay? Like because then to which tab you'll be sending the response back to? Yeah, this is exactly what the question was. What happens when a device make multiple simultaneous requests? Because the response would be saying that would be having the exact port number even in the destination. So how are we going to handle it? So what this is a typical OS thing. So whatever request you are making to the router, what it does is what your OS does is, let's say this is the IP address that you're trying to hit 172.27 something. For every request, your OS associated with some random port number because your OS has some 65,000 port number, which were around 15,000 or something called ephemeral. So it's like temporary use and throw port numbers. So what happens is whenever your OS figures out, okay, I have to make this request, your OS picks one of the ephemeral address and just randomly attaches it to the IP address. So when your request is going out of your PC itself, it doesn't only have google.com, it also has the colon, some random port number. So in this case, what happens is, uh, yeah, in this case, you also have a port number attached to your, yeah, I have a thing like, yeah, this is also something I just want you to look at the number 1, 2, 3, 4, 5 sequentially, and you can follow me on that. Consider SA is the source IP address, DA is your destination's IP address. In the first case, the computer 10.0.01 with its private IP is trying to speak with uh, some one, like you can see the DA at the top right corner. It's trying to speak with that guy. So the typical flow is the the packet is sent to your router, what your router does is it creates this table, something called NAT table. Yeah, it's called NAT table. And it not only it associates not only it associates your okay like 1 minute private IP address port and public IP address port. So okay, like probably this is sort of incomplete. So it creates one more port. You can see the you can see that thing, right? The private address port is actually instead of only having the private IP 1723, it also has something called yeah, this is the actual table. Sorry, instead of only having the private IP and the public IP, it also has ephemeral port like 1723, which is given by the OS itself. So you have an association saying that the IP which made the request, the private IP which made the request is this, and this is the port number which also the OS has given. And while sending the response back on the internet, it sends it uh, with the same guy. Like it just attaches the public IP, which is 17. In this case, you can see, right? It's the public IP. Okay, like this diagram is sort of confusing. I'll just go here. What it does is it just instead of just having a mapping of private IP to the port number, which it has appended before it's sending it to the public internet. It also has a it also has the mapping. Okay, what's the actual port number? What's the actual private port? Which okay, like this is because I thought the diagram is helpful, but if you have understood this concept, it should be clear because our issue was when the response is coming back, it would be saying that the intended guy is uh, okay, like how okay, if I'm just saying that for every private IP, I'm just associating it with a port number. Let's say for like assume that for every computer one, I'm saying that it would be 450. If we are having just this table, when the response is coming back, it's going to be pretty hard because the destination will always be saying 4500 is the port number. Uh, Whatever like response, like pi response the computer one has made, every response is going to say 4500. And you can send it to the how does you associate it with the tab. Let's say that's the exact word that I was missing. How do you forward it to the right tab? You also have to have this is the tab that made this google.com this request. So while before even sending it to the router, your OS will make sure it sends it in this format. Like so every request like google.com will be followed by colon random number. So you will forward it to the right port. Like I think because yeah, we can probably come to it later because I thought this NAT table this is pretty not expressive, like what I'm trying to say. But yeah, probably we are actually ran out of time. But is it okay if we extend it for some 15 to 10 minutes or like uh, I'm just because actually I'm just trying to rush, I guess, because the time is almost 8:30. Hello. So I have some, or hello.
Yeah, bro, actually, we got out of the time and we just rushed up the topics first.
What like yeah, we actually have ran out of time. So what should we do actually now, or should we move it to some other time, or
Yeah,
like should I continue? Or
yeah, you can continue. Just go first.
okay, so I can try sort of rushing because like yeah, like I'll just give you a very high level overview. Maybe we can skip oversight layer. We can just directly look at something called subnet. Like subnetting is also because this is one of the main concept of IP address. So I'll just explain it fast. So what subnetting does is subnetting let you divide the internet into sub networks, like yeah, network into subnetwork. That's what subnetting means. So think about, let's say you have a single switch and you have every computer connected to the single switch. Let's say almost all the network is connected to the single switch. So what will happen? So we were seeing, right, like, because what if it takes the same approach as of switch actually floods when it doesn't know who is some IP or who is some MAC. When it doesn't know, it broadcasts. So in this case, you can see that what the same thing happens in the internet. So in case of internet, what if the same thing happens? Like you will just don't know where who someone is. So it just will ask like, can you tell me like who is this IP address? So literally all of them will be getting scammed. Expect the one guy who will be returning with IM. So so it's very important to dissect the internet into subnets. So that's what IP lets you do. Called IP has this structure called network address and host address. So whenever you say this is the network address part, so you can pinpointly say, okay, all the guy who has this network address suffix will belong to the same network. So so just assume that with every host, which is some section, which has the same network address prefix, will belong to the same network, will belong to the same LAN. And in this case, you can see, right, and with the help of subnets, you can you can organize the internet like this. You can organize the internet like these chunks. This, like all the suffix just goes with 192.168.xx. This I'll like, because as I was telling, the internet is nothing but a networks of network. Internet is a network of network. So here the middle guy has a network that says all of my subnetworks has the prefix 192.168 this, and all others. Uh, you are saying that all the subnetworks has this prefix 192.168. So whenever you are making a request to, let's say, 200, when the request is coming, this router can just say, okay, I only have this prefix, so I'm not going to take this request. So it can just discard it. So in this way, you're not spamming these much computers. So with the help of subnet, with the help of this prefix, with the help of this network address, you are preventing spamming. You are literally preventing spamming. So in this case, you can actually, so this is what subnetting does. Let me also move like forward. And there is something called subnet mask, which is I think very technically dense, like, or bitwise thing. So the thing is, every computer will have something like an IP address and a subnet mask. So which let you and like, let's say you are trying to make a call to some IP address called 200. So with the help of subnet mask, you can figure out the destination belongs to your whether it belongs to the internet or whether it belongs to the LAN. So let's say you have something called subnet mask. With the help of subnet mask, uh, you can figure out the network portion. Uh, in this case, let's say my subnet mask is this fancy number 255.255.255, which just means 24. So with the help of this 24, I can get the network portion out of let's the destination IP address. So I can figure out, okay, I myself, I'll check my network portion, I'll check the destination's network portion, and then I will say, okay, if the network portions are same, I don't have to send it on the internet. This will be done by the router itself. This will be done by the router. The router just checks the source IP address, and it will just check the destination's IP address. And if they both belong to the same network portion, and it doesn't have to send it to the internet. It just knows, okay, this I can send it internally, like, because that's a LAN thing. Clear about it, right? That's what subnet mask does. It just let the router knows whether I have to send it to the internet or whether it belongs to my network, the LAN network. with like which is this is just a AND operation. Uh, so yeah, like typically this is a very fancy thing. Like you might see IP address with a /24 or /16/8 written, which is just the subnet mask of it. So the it can like it can be like the smaller the subnet mask, the bigger the network uh, because you are it's just an AND operation. So just assume that if the subnet mask is getting big, like it doubles it every time. In this case, if it's /23, it will be 200 and 512. If it's /22, it's that 1028. It keeps on doubling. And you can do the math. You can read about subnet mask, but subnet mask so the next time you see an IP address with a /24, which you are going to see a lot of time, that's what it does. It just let the router know whether the packet is at the outside world or whether it's at the inside world. And so you don't. So actually, we are almost at the end of the talk. So you can see, you must have seen this, like because you might have even be scared of like I used to get scared of this because this is a very common window which sort of let you configure your IP, which sort of let you configure your the way your IP address is assigned and all those stuff. So the next time you see it, now you know what IP address is. This actually corresponds to IPv6. And the next time you see subnet mask, because we have already covered almost all of it. We have already seen what a subnet mask does. We also have seen what a default gateway does, which is just nothing but just the address of your router. And there are also ways, because mostly you will not be touching it because you should be using that obtain an IP address automatically. So what it does is it uses a protocol called DHCP, which makes, I was telling you, right, your router is the one who assigns you random IP address whenever you connect to a Wi-Fi. So you might just keep the obtain an IP address automatically. You must be using that setting only, but this is a typical thing, and you probably also have seen the below thing, the DNS server. So there are different DNS servers. You, like you probably will be using your ISP's DNS resolver, but you can also use Google's DNS server, which belongs to 8.8.8. Like you can read about it. Like what's the how can I change my DNS server, and how can I change my IP address? How can I assign a static private IP to myself? How can I change my default gateway? Which and all, or future, like which is for you, like which is for your experimentation. And I'll be going to skip this OSI layer uh, because this is you can okay, this animation, okay, fine. You can learn, like there are to just give a very brief introduction. The OSI layer has these 7 layers, which is nothing but just a conceptual framework. It's not anything very core, very concrete or something, but it just let you, uh, which is a way of assign separation of concern. If you look at code, there is a concept called separation of concern. So every layer will be handling some task. So whenever some issue happen, you'll just have to go and look at the layer, the protocols related to the layer, and you don't have to look at the whole network, or like you just have to look at those layers in general. And also that's why the OSI layer, you might be understanding it, like because you have computer network in your 5th semester, I guess. So you'll be learning about OSI layer, like that's what, like. But the thing is, there is another thing called TCP/IP model, which is nothing but just a concise way of writing. Like it just condenses the top 3 layer into one, and other layers as three. Instead of the 4 layers, instead of having 7 layer, it only has 4 layer. And this is what the TCP/IP model, like now people mostly discuss about TCP/IP model because it's more easy to understand, which has less noise. And finally, like I just have to, I just, as I promised you, like you have to understand the uh, end to end, how the data flows across the internet, which just takes 5 minutes. So just bear with me for the next 5 minutes. So let's say this is your network infrastructure. Let's say there is a process. Let's consider this as a tab. It's a tab, and like this is the tab which is making the request, and you are the sender, and you have a private IP. And consider that router is one public IP, that consider that is your default gateway, the router one, and all the others, like, and look at the right side, which is the receiver's public IP, and there is the, like, not public IP, which is, but assume that this is the, you have to somehow reach, the sender has to somehow reach the receiver, and how is he going to go forward? And this is the major, this is going to be the, like how the data flows through the internet. So, so the thing is, when the packet, so you have, like, we must have covered the the port part. If whatever request you are going to create, the the OS is going to assign a port number to it. Let's say the segment part is related to the port number, which is saying the source address, the source request has the IP address of 4200, which is chosen for the request by your OS. And since you are sending request to an HTTP, like you are sending a request to, let's say, an HTTP website, so the default port is 80. So 4200 is the request IP, request port number. The 80 is the response port number. And then there is a thing called packet. What it does is, it's an encapsulation. So segment is encapsulated as a thing inside something called packet. The packet holds your IP address, like, sorry, yeah, IP address. So the packet has the source IP address and the destination IP address, and it also tells you what's the protocol that's being used, which is TCP, which I should have explained, but we don't have time. But assume that segment has the port number, packet has the IP address, and frame has the, yeah, like the right side. I'm talking about the right side segment. The right, so like the frame has the MAC, sender's MAC and gateway's MAC. So in this case, yeah, this is how the initial packets look like. When the sender just sends, like, just observe how only the frame changes across the itinerary of this message from the left side to the right side. The frame just have the sender's MAC and gateway's MAC. That's why it's called hop to hop. MAC address is just used for going hop to hop. Hop to hop means from one device to the next device, because as I've already told, somehow you are connected with someone on the internet, but there are devices that's connecting you. Like, so it's always a hop to hop. It's not like a single jump. So in this case, this is the default setting. You are initially sending to the gateway's MAC, and what happens is your gateway just looks at the destination's IP and just figures out. What it does is, here you can see that the port number has actually changed. It's not the packet, the source address has changed. The source address is not 10.10.5.6. It's the okay, it's actually the source address. The source address, it's actually the public address of the default gateway, along with some default port number, which need not be 4200, which can be anything random. And then what your router one, after doing the NAT translation, it figures out, uh, it consults. Like router one figures out, okay, should I send it to the network, outside the network, or within my network itself? It just does the subnet masking and stuff, and it figures out, okay, 20.10.5.6 is not within my network. It's going to be outside the network. So what it does is, it figures out something called, it has something called a routing table, which I'm going to like. Okay, fine. So it has something called a routing table, which knows, okay, for this IP address, this is the best possible hop, which is the best possible way. So it consults its routing table, and what it does is it figures out, okay, router 2 is the best possible guy, like to send the request to. Here you can see it just changes the source MAC to the gateway's MAC and the destination MACs to the router's MAC. And now router 2 also does the same. It receives the packet uh, and it also does the exact same thing. It also checks, okay, whether this IP belongs to me. Whether it belongs to me, just assume that it is not. So the router 2 also figures out by using its subnet mask and stuff whether 20.1.5.6 belong to my local network. So it figures out, okay, it's not. It also checks out its routing table, which is a table that is filled by some algorithms like BGP, and there are algorithms that tells every router what's the best possible hop to go to the destination address. Like in this case, the best possible way to go to 20.10.5.6 is router 4. So it figures out, so what it does is it just changes the MAC address to routers to MAC and the frame to router 4's MAC address. So the same process continue. Router 4 is also check whether this IP address belongs to me or not using its subnet mask, and it figures out, okay, it's not. And then what it does is it consults its routing table. It figures out, okay, router 6 is the place where I should go. And yeah, like then it changes the frame back, the MAC address. Frame in the sense the MAC address. Routers 4 MAC to router 6 MAC. So that's why, like, when router 6, this is why it's called hop to hop. Like you can see only the frame is being changed, and every router just checks, okay, is this somehow belongs to my local network. And finally it arrives at router 6. Now router 6 using its subnet mask figures out, okay, indeed this packet belongs to myself, like someone within my local network. Still it doesn't know. So what it does is what it does is now it changes its frame to router 6 MAC to the receiver's MAC. Now, because of how local area network works, indeed this time it's not going to go to another router. If we have looked at how local area network work, if you exactly figured out, okay, the receiver MAC using its switching table and all, it figures out, okay, this is where it is actually. This is where the receiver is actually is. So your receiver actually figures out, okay, which is your laptop, and also it does the NAT translation and stuff, which I think I missed because it also, in this case, what happens is your frame is removed and now your packet, now the destination. Okay, so sorry, right? It doesn't do NAT translation because there's no need for it actually because yeah, there's no need for it. So you just change the frame from router 6 MAC to the receiver's MAC. You will now the computer, now the server, google.com has received your request. Now it realizes, now the receiver realizes, oh my God, like this is something that's written to me, like this message is intended for me. So it keeps on removing layer by layer. Like what it does is it just removes the layer, the packet layer. Now there can be several processes that's running within the same MAC, like within the same receiver, because google.com, YouTube might all be hosted on the same, let's say, on the same mission. So what it does is it figures out the process. Now in this case, it's port number 80. So it just keeps on removing layer by layer. In the previous case, you can see it removed the packet section. Now in this case, because it knows it belongs to it, its IP address. Now it has to figure out which process it has to go. Now in this case, it knows, okay, I have to forward it to some application that's running on my port 80. So in this case, it would be your google.com, and finally the data is consumed. Now the same process happens at the reverse side, but I'm not going to go towards it. Now you can see how the internet works, like because at every like how hop to hop thing happens and stuff. Yeah, like hopefully you have understood how the communication happens from one process to the other process. And this is the end of the presentation. There's one last slide which just summarizes what we have learned. Are there any questions in this sections? Are there any question? If not, I can move forward actually, which is the last slide. Okay, moving forward. Okay, what we have learned, like what we have learned is what is an IP address, what are the different IP address, and what's a MAC address, and how MAC address is associated. It's still unique, but still it's not deserving to be called the address of the internet. And the second thing is how like and how the DNS works, and how do you register a domain, how do you get a public address, and the third thing is what's NIC, and how devices are connected within a LAN, how one device within the same LAN is able to connect with another device on the LAN, same device on the LAN, and how the package within the LAN is being forwarded, how the switch does it, and what are the issues, what are the potential vulnerabilities in uh, forwarding the packets within the same local area network, and what's a switching table, and the second thing is what's subnetting and how it helps organize the network in some way that creates less spam and that makes the internet more organized, that makes the routing itself efficient, and and the itinerary of packets across the internet, which is the last diagram which we have seen. And finally, OSI and TCP, TCP/IP layer, we are not able to cover it, and probably yeah, but you can, with the knowledge of these things, you can actually cover it on your own, which is pretty theoretical. So, but yeah, like thank you, and thank you for staying for 23 more minutes. Thank you. Uh, any questions? Yeah. Uh,
Thanks a lot. So even after time, you are spending so much interest in teaching us. Thanks for everything.
yeah, sure. Thank you. Yeah. Uh,
Thank you guys for your participation. If you have any doubts, you can ask.
yeah, like, uh, okay, sure. Okay, will the IP address change? Okay, will the IP address change for every time we connect to the? Yeah, correct that. To answer a few of the questions, yeah, indeed, it was true because I was telling this thing right because your router might be having some limit fixed limit. It can only have 25 simultaneous connections. So if we are assigning everyone the static IPs, so what might happen is even though the first let's say your connection has the limit of 10 and there are 10 people who are already connected to the internet, and then they have been assigned static IPs, and they are no more there. So they just disconnected and went away. So even though there are five new slots are there, new people won't be able to join the network because the IP address are exhausted because if you are using static IP. So the router uses something called dynamic IP address, which is using a protocol called DHCP. So DHCP is actually a protocol which lets you, DHCP is actually a protocol that makes this possible, the dynamic allocation of IP addresses. You can read about it. You can read about the difference between the static IP versus dynamic IP and how DHCP helps in the process. Not IP address, but your device MAC address. If you use, okay, actually, yeah, but MAC address are mostly because since MAC address are unique, it's related to your NIC. It won't change. It will not change. But I think they have introduced few things like recently, which makes your MAC address itself dynamic. But currently, as far as I know, since MAC address is associated with our NIC, which is a hardware thing, so you cannot. It's static. MAC address is static, but your IP address tend to change. But using some configuration, you can ask your guys to change the IP address. Through software randomized it through software randomized. Like, if this question is about if through software randomized, I'm not like if you look at the publicly hosted thing, right? Most of the cases it won't change because those will be assigned a public IP. But I'm not exactly sure about the question, but to tell like publicly hosted things like Google.com or someone, they might be having several IPs. Like that is another thing. They might be having several IP, but whenever they also will be having static IPs because I told you right because dynamically changing of IP is going to be causing so much issues in DNS at DNS level. So probably if you are hosting a website the hosting service will be assigning you a static IP so that the DNS records are getting invalid every time. Like, yeah, that's all. Like, and okay, any other questions? Like, and what exactly through software randomized at every connection? I'm not exactly sure. Like, you can turn on your mic and ask the question, or like you can also post it in the chat. Uh, yeah, from where the IP and MAC. Oh, okay, fine. So one thing is MAC address. I've told you right, like MAC address, it depends on a hardware. So whenever you are getting a Mac, whenever you are getting a laptop or something, the manufacturer itself. If I go back to the slide, uh, wait, let me just okay, only slide only. Okay. So if you are going back to the MAC address, and, okay, if you are going back to the MAC address, you can see that the first 12 digits, the first 24 digits are assigned by, let's say, for Apple, this 24 digits are okay, for the first 24 digit, if you're getting your laptop, which has NIC for Wi-Fi and stuff, that will be unique. For Apple, it will be unique. Apple itself has several identifiers, so it will be one among them. So you can uniquely identify whether given a MAC address, you can exactly tell who is the manufacturer of it. So whether it be it Apple or be it Intel, be it Cisco, whoever who manufacture it. And the second section is unique. Like if let's say the first device that's created under that unique identifier might be assigned the number one, the second might be two, and stuff and stuff. It's same as how our roll number is like 180701219, right? The 180 tells that the batch belongs to 2018, and the last few digits mentions that which class does he actually belong to. So the same structure uh, so the same structure we do use like here. So so MAC address, to answer the question, MAC address comes from the manufacturer himself and it doesn't change. But uh, IP address or like if you look at the local IPs are assigned by your router, but there are public IP addresses which is assigned by because whenever you are hosting a service, right? Who is assigning you the public IPs? The hosting service. What the hosting service does is they buy a set of IPs or hosting service, or like in your case, your ISP is assigning a public address to your routers. So what those guys does is those guys buy it from someone called ICANN. That's some internet, some organization. So what they do is your ISP will buy a range of IP address. Let's say they'll buy that's why the Airtels or Hathaways or your ISPs, public IPs, all are almost same because they buy a bunch of IP address. They create this IP pool, and whenever a new customer is coming, they'll assign one of the public IP to the router, and which may or may not be dynamic. I'm not exactly sure, but your ISP buys these ranges in bulk and assign it on the go, like on the go in the sense like they'll assign it on the go. Whenever new customer come, they'll assign one by one. So that's how it actually works. And I was talking software randomization. What does it mean? I'm not sure exactly. Software randomization. Okay. Is it like, are you talking about by knowing the IP address, can we find the sender's location? Uh, okay, that's actually, I'm not sure about the software randomization of MAC address. Are you talking about, can you spoof your MAC address in some way? Like I was talking about MAC address, can your MAC address be changed in such a way? If that's the thing, yeah, it is completely possible. You can you can give a false impression that because you are the guy, right? You are actually because the packet that is being sent is the only source of truth who is sending the request instead. So they can completely say that, uh, like I'm coming from here or something. That's why this is a very good because in your router you can have this MAC level filtering. So you can, if you are the router's admin, you can log into your admin portal and say that I only want to enable these MAC addresses or I want to disable these MAC addresses. Whenever a packet is coming from this MAC address, since MAC address or unique, you can actually say that whenever it's coming from this MAC address, block this. So if it's your brother or sister and they exactly know what you have done, so they can spoof it. So they can, if they know your MAC address, they can just pretend to be you and they can just bypass the blacklisting or like that thing. So it's completely possible, and there should be some ways to to find the spoofing and stuff, which I'm not very sure, but it's completely possible to spoof your MAC address. And by knowing the IP address, can we find the sender's location?